So let us try to identify the different parts of the parabola by simply using our formula here as our guide. So let's start with the opening. So we have here x as being squared. So if you try to look at the opening on our formula as a guide, so we've got here standard equation. So you are just to trace where your x is squared. So on this part here, our x is the one being squared and also with this one. So it's going to be either upward or downward. But if you try to look at the number here multiplied to a non-squared variable, we do not have a negative. We have a positive 8 in there. So looking at the other side, we have here a positive 4a. So that means to say that we've got an upward opening. So our opening is upward or up. So let's now go for the vertex. Now for the vertex, we cannot rely on the formula here as our guide, but we are going to manually identify our vertex in there by simply looking at our equation. So you would say, if you've got x in here, you are to check if you have a number added or subtracted to your x. But if you don't have, just like this one here, we don't have a number added to this x here and subtracted to this x, so automatically that is a 0. Next one on y, we don't have any number added to it or subtracted to it, so that is also a 0. So this is now our vertex in which our h is 0, our k is 0. So let's now move to the focus. So if you try to look at the focus in here on our guide, we have our downward. So you trace that one here on downward. We've got f, which is h, and then k plus a. So our h there is 0, and then our k there is 0 also, and our a is unknown. Now to identify your a, all you have to do is to look at the number multiplied to a non-squared variable and automatically divide that one by 4. Because this one here, if you try to look at our pattern on the standard equation, this is supposedly our 4a. So since that is 4a, which is equal to 8, all we have to do to identify a is to divide that by 4. And so with that one, so our a is 2. So going back, so we have that one as 0 plus 2. So simplifying that one, we've got that as 0, and then 0 plus 2, that is 2. So our focus there is 0, 2. So next one, we have to go through with the directrix. So our directrix here is y equal to k minus a. So again, we have y equal to k minus a. So y will be equal to our k there is 0, and then minus our a there is 2. So simplifying that one, 0 minus 2, that is negative 2. So our y there will be equal to negative 2. Next, on the axis of symmetry, we have that one as x equal to h. So x there will be equal to 0. And then let's go for the endpoints of the latus rectum. This one is our endpoints of the latus rectum. Notice that we have here h plus minus 2a, comma, and then k plus a. So all we have to do is to plug in. So let me just have that one here. So again, we have h plus minus 2a, and then we have comma, and then k plus a. So simply plugging the values there. So we have h is 0, and then plus minus our 2, and then our a. So we have a here, which is 2. And then we have comma, and then our k there is 0, and then plus our a there is 2. So simplifying that one, this is now 0 plus minus 2 times 2, that's 4, comma, and then 0 plus 2, that's 2. So out from here, we can come up with 2 points. First, we have our 0 plus 4, and then comma 2. The other one is the 0 minus 4, and then comma 2. Simplifying that one, we have now on our endpoints of the latus rectum, we have 0 plus 4, that's a 4, and then comma 2. And the other one, which is 0 minus 4, that's a negative 4, and then comma 2. So those are our endpoints of the latus rectum. Now, going back to the length of the latus rectum, the length of the latus rectum will always be 4a. So once we multiply our a with 4, so 4 times 2, this is equal to 8. So our 4a there is 8. Now, simply looking at our equation, we would know right away what's the length of the latus rectum by simply getting the absolute value of the number multiplied to a non-squared variable. Or get the positive of that one. So that will be the length of the latus rectum. So let us have now y squared equal to negative 4x. Let us identify the opening first. So our opening here is with, if you try to look at y, we've got that squared. So we will be looking at the standard equation wherein our y is being squared. So that is with this two only to the right or to the left. Now, moving on the other side, we have negative 4 here. So we will be looking at where our negative 4a is. And that is where we have our to the left. So the direction or the opening of the parabola here is to the left. So let's have our vertex. So vertex here, we are just going to rely on our equation here. If you try to look at this, this is the first variable in which that is y. So you have to be careful on that one. Whatever number is attached or added or subtracted to it, you must have to write it on the second coordinate. So since we don't have a zero, added to it, any number added to it or subtracted to it, so automatically this is gonna be a 0, and I'm writing that one here on the y coordinate of the vertex. And on x here, since we don't have a number added or subtracted to it, automatic that is also a 0. So this is now the vertex in which this is our h, this is our k. So going over to the formula here, we have for the focus, we have h minus a, comma k. So we have our h as 0, and then we have minus our a there. We don't know the a yet, but if you try to look at this, the negative 4 here, using this one here is our negative 4a. So negative 4a, that is equivalent to negative 4. So once you divide that one with negative 4 and so with this one, our a there is equal to 1. So since a is 1, so we'll be replacing that one here. And then we have comma, and then the k there is 0. So simplifying that one, this is now 0 minus 1, that's negative 1. So we have comma and then 0. So that is our focus. So we've got negative 1, 0 for the focus. So next one, we go for the directrix. We have that one as x equal to h plus a. So x is equal to, our h is 0, and then plus our a is 1. So 0 plus 1, that is 1. So our directrix is x equal to 1. And then for our y is equal to k. So our k there is 0. So we have our y equal to 0. This is also in the pattern for the vertex and so with the focus. The common number in there that will be under our axis of symmetry. And then whatever is the coordinate of that one, since your 0, 0 here is on the y coordinate, then you are going to write there y equal to 0. So anyways, you can use the formula if that will be comfortable for you. So let us now go for our endpoints of the latus rectum. So we will be using h minus a, comma k plus minus 2a. So we have that one as h is 0, and then minus a, which is 1, comma, and then k is 0 still, plus minus 2, and then our a is 1. So simplifying that one, this is now 0 minus 1, that's negative 1, and then 0 plus minus 2 times 1 is 2. So simplifying this one still, so we've got now 2 points, which is negative 1, and then 0 plus 2, and the other one is a negative 1, 0 minus 2. So simplifying this, we have negative 1, 0 plus 2 is 2, comma, and then we have negative 1, 0 minus 2 is negative 2. So our endpoints here is negative 1, 2, and then the other one is negative 1, negative 2. And going over to the length of the latus rectum, you can do 4a. So we have that one as 4 times a, which is 1, that will be equal to 4. Or simply whatever is here, just make that one as positive. Then that is our length of the lattice rectum. Going over to the next example, we have the x minus 2 squared equal to negative 16 times y plus 1. So again, opening here, we are going to determine that one using the pattern here for the standard equation. So we have x minus 2, so meaning to say our x is the one being squared. So we have two options, the upward or the downward. But since here this is negative 16, so we will be locating also negative 4a. So this is negative 4a, and that one is downward. Or we can write that one as down. Next, we have the vertex. So based on the equation here, we've got an x on the first one. And then we have an attachment which is minus 2. So since this is minus 2, writing that one on the vertex, we negate that one. That will be positive 2, comma, and then we go over to y. Y is added with 1. So plus 1, that will become here negative 1. So that is now the vertex. And again, this is h, this is k. And we go for the focus. So our focus is h, which is 2, comma, k, which is negative 1, minus our a. Our a is going to be determined by this number here. We've got negative 4a, that will be equal to negative 16. Divide this by negative 4 to get our a. Our a there is 4. So that's our a. So subtracting, again, going back here on the focus, we have k minus a. So we have k for negative 1 minus our a, which is 4. And then simplifying that one, we've got focus, which is 2. And then negative 1 minus 4. Since we have the same negation here, or we have the same sign here, negative, negative, we'll be adding the numbers. We've got 5, and then copy the negative. So we have negative 5 for that one. So under focus, we've got that as 2, negative 5. So next one, we go over to the directrix. So we have y equal to k plus a. So y will be equal to our k there is negative 1 plus our a is 4. So simplifying that one, our y there is equal to negative 1 plus 4. They have different signs. So we subtract the numbers. 4 minus 1, that's 3. And then we copy the sign of the bigger number. So that should be positive. So our directrix there is y equal to 3. So for the axis of symmetry, we know right away if we try to look at the vertex and focus, this should be the 2 here, which is common, and that is on the x coordinate. So that should be x, or equal to 2. Or if we go over to the formula, we've got that one as x equal to our h, which is 2. So again, axis of symmetry, that is x equal to 2. Let's go for the endpoints of the lattice rectum. So we have that one as h plus minus 2a, comma, k minus a. So we have our h, which is 2 plus minus 2 times a, which is 4. And then comma times our k there. Not times, but comma, and then open parenthesis. And then we have our k, which is negative 1, minus our a, which is 4. Oopsie, there should not be an open parenthesis. Okay, there. Next one, we are going to have this one simplified. So we have 2 plus minus. This is 2 times 4, that's 8. Comma, we have negative 1 minus 4. They have the same sign. So we'll add 1 and 4. That should be 5, and copy the common sign. Simplifying this one, so we have to break it apart. So this is now 2, starting off with plus, and then 8, comma, negative 5. And then we have also the other one, which is 2. And then we go for the second operation, which is minus. And then 8. And then we have negative 5 for that one. Simplifying this one, 2 plus 8, that's 10. And then comma, negative 5. Comma, this is 2 minus 8. This is smaller number subtracted with a bigger number, so that should be a negative. And then 8 minus 2, that's 6. So we have negative 6 for that one, and then negative 5. So these are now the endpoints of the lattice rectum. So we have 10, negative 5, and then we have negative 6, negative 5. This may come in any order. So length of the lattice rectum here, we've got this one as negative 16. We can use 4a for that one. So you can have 4 times our a, which is 4. That will be 16. Or simply looking at it, we've got negative 16 for that one, so that should be 16. And lastly, we have here y squared equal to 12 times x plus 5. Going over to the opening, we know that this is y being squared, so we will be looking at this one and that one to the right or to the left. So looking at the other side, this is 12, which is positive. So we will be locating that one as 4a. So that should be to the right. So this is now right on the opening. And then vertex, we just have to get the x and y coordinate of the vertex here as the attachment on the x and y variable on the equation. So we start with y here. We started with y. So y doesn't have any attachment. So automatically that should be a 0. Attachment means nothing is added or subtracted to y. So that should be a 0. So next one, we've got x plus 5 here. So your x is added with 5. So this is positive. This will become negative in here. So that will be the vertex. And then we go for the focus. Since that is to the right, so we are to look at the focus on to the right. So we have here F, and then we've got H, which is, this one is H, this one is K. And by the way, finding our A, so let's try to find our A first. So this 12 here is our 4A. So 4A is equal to 12. Dividing this by 4, and so with that one, our A there is equal to 3. So we've got now A. So going back, so we have focus is with H, which is negative 5, and A added with A, which is 3, and then comma, and then your K, which is 0. So our focus here will be negative 5 plus 3, that's negative 2, comma, and 0. So again, focus is with negative 2, comma, and 0. So directrix, so we have here x is equal to h minus a. So x will be equal to our h there is negative 5 minus our a there is 3. So negative 5 minus 3, so negative, they have the same sign, so we are adding 5 and 3. So x here will be equal to 8, and then copy the same sign, that should be negative. So x will be equal to negative 8. So next we go to the axis of symmetry. So we have y equal to k, so y will be equal to our k there is 0. So next one, we are going to look at our endpoints of the lattice rectum, in which we have that one here as h plus a, wherein h is negative 5, and then plus a, which is 3, and then comma, our k there is 0, plus minus 2 times a, which is 3, and then simplify. So this is now negative 5 plus 3, that's negative 2, and then we have 0 plus minus 2 times 3, that's 6. Simplifying that one further and breaking that one up, this is now negative 2, 0 plus 6. The other one is negative 2, and then 0 minus 6. Simplifying that one, we've got negative 2, 0 plus 6, that's 6. And then comma, negative 2, 0 minus 6, that's negative 6. So writing that one here, we've got negative 2, 6. And then we have negative 2, negative 6 as our endpoints of the lattice rectum. So length of the lattice rectum, we've got that one as 4a. So our a there is 3, so 4 times 3, that's equal to 12. Or simply looking at this one here, this is 12, so that should be our length of the lattice rectum. So that's it. So I hope you were able to follow through with the discussion. So I'll see you again in my next video.